దీన్ని ఇంకొకసారి కొంచెం
అదేం లేదు. అది
ఎందుకంటే జస్ట్ ఏదో
కథలు ఉంటుంది.
మాత్రమే
నేను మొన్న చెక్ చేసుకోమన్నాను ఒకసారి రికార్డింగ్లో. Yes, good morning, students. Hope you have followed my instructions and have gone through the COs, the course outcomes, program outcomes, the program educational objectives, the program specific outcomes. We should be comfortable at any time. There is a chance of MBA expert joining us. There is an MBA expert joining us. Please be careful, be prompt, and be responsive. Respond.
Okay, sir.
Yes, good morning. Only 19 students joined. Ask them to quickly join. Let me wait for a couple of minutes. Ask your friends to quickly join, Amma. Yes, I'll go ahead with the class. It's almost 9:05. Huh? Please have a glance at the syllabus also. which is available in the website, and which I've shown it to you on day 1. You will definitely have questions on that if the expert member joins us. And preferably you should be comfortable. Hope the screen is visible to you. Preferably you should be comfortable with these COs. The first CO is with respect to the basics of AI, that is fundamental understanding of AI. The second one is with respect to the problem solving, the knowledge representation and learning. The third one is with respect to the AI application techniques in intelligent systems, expert systems, and neural networks. Keywords, just remember the keywords. And the fourth one is with respect to uncertainty. Just remember that way, okay? Okay, I'll just try recalling the concept. Is my screen visible to you?
Yes, sir.
Yes, sir.
Thank you, Amma. And please enable your videos. Please do not turn down your videos, just mute and turn on the videos. In the last class, we had an introduction to this, the logic. As I said, logic is a type of formal language. This is all history. In general, logic is a type of formal language, which is normally used to represent knowledge. And to represent knowledge, we require the basic syntax and the semantics. Because that representation should convey some meaning, and that should be represented properly. So we have considered two concepts, namely the propositional logic and the predicate logic, and we focused on the propositional logic to a certain extent. And what is a proposition? As said in the last class, proposition is a declarative statement. Proposition is it's raining, that's a proposition. It is sunny, that's a proposition. If it is raining, it will not be sunny, that's a proposition. So a proposition refers to a declarative statement that can be either false or true, but it cannot be both. Always remember that. People may try to confuse. Can a declarative statement provide both the truthful values, that is true or true and false? That will never happen. It could be either a true statement or a false statement. If all the propositions are true, then we normally call it as tautology, and if they are false, they are fallacy, we call it as, according to the mathematical propositions. And from the given set of propositions, we can infer a new proposition using certain inference rules. Okay? And these are the basic properties. One is consistency, the second one is soundness, and the third one is completeness. I request everyone to turn on the video. So these are the three key properties for logical systems, that's consistency, soundness, and completeness. See, if you say with consistency, suppose if there are two theorems, they should not count. One should not specify the positive and the other should not specify the negative if both theorems represent the same concept. So they should never contradict with each other. The inference rule shall never allow a false inference from the true premise, that is before to the implication. Okay? And completeness, there are no true sentences in the system that cannot be proved in the system. That means we should always have all the true statements. Suppose if there is at least one true sentence which cannot be proved, then it is not complete. That's how you have to understand all these three properties. And all this was discussed in the previous class. What is a well-formed formula? Okay, and proposition normally is, as said in the last class, these are all the connectors or the logical operators. The not, and, or, implies, equivalence. Besides these logical operators, we have two more connectors which we call them as universal quantifier and existential quantifier. Universal quantifier means for all. Universal quantifier means for all. Hope you know how a for all appears. Let me say this is how for all is. And existential quantifier, there exists. So these are also there, but these are not logical connectors. That's the reason they have not been listed over here. Okay, yes, moving ahead. And in propositional calculus, the thing that is very important is, the concept that's very important is the concept that's very important is the well-formed formula. And what is a well-formed formula? Well-formed formula could be a simple sentence or simple string, or it could be a combination of symbols. All this was discussed in the last class. I'm trying to recall because we have the connectivity to the previous class. And well-formed formula should have these basic properties. And any propositional expression which is called as a well-formed formula, they should satisfy these three properties. One is any simple atom or unit, or we also call it as an atom, is a well-formed. Suppose if it is raining, if I represent it by A is equal to it's raining, and that's a that's a well-formed formula. The negation of that also is a well-formed formula. And if we use the connectors, if you claim that alpha and beta are two well-formed formulae, then the logical connectors, if you use alpha and beta, alpha or beta, alpha implies beta, and alpha double implies this, they are also the well-formed formula. These are the three properties. And in the previous class, I've also given you the truth table of this, and I've explained how this A double implication, that is biconditional. One second. This was also given in the last class, and I've shown you how these two are obtained. A implies B and A biconditional B. Okay, just recall what is taught you in the last class. And this is the truth table. So based on this truth table, we are trying to prove this proposition. A or B and not B implies A. This is as good as simple preparing a truth table, which you might have come across in digital logic design or computer organization. Okay, and this I've taught you in the last class, and these are the different equivalence laws. And besides these laws, I've given you one also, that is elimination. A implies B, that is implication elimination, which can be given as A implies B can be written as not A or B. This is, if you want to eliminate this implication, you can rewrite it this way. That has not been presented over here. That's the reason. Because these are the basic equivalence laws. These are the basic equivalence laws. And using this equivalence, we can transform to one point to the other point. And this is where I stopped in the last class. I do have 38, 39 students. And as long as I'm in the class, please do not leave the session, even if it is beyond 9:50, okay? Till I get a call from the HOD, I'll be continuing the class. And this is where I left you in the last class. Yes, the propositional logic. The propositional logic deals with, see, I've highlighted validity, satisfiability or consistency, and unsatisfiability or inconsistency of a formula, and the derivation of a new formula using equivalence laws. What are those equivalence laws? These are the equivalence laws. All these are the equivalence laws. So using this propositional normally proposition logic will deal with all these three properties, that is validity, satisfiability, and unsatisfiability. Okay, and every row of a truth table for a given formula, this is what we have done. See, this is what every row for the given set of values for A and B. Those are the truth values. For a given formula, alpha is called its interpretation under which the value of a formula may be either true or false. That's what we have seen. See, if A is equal to T and B is equal to T, A or B is true, not B is false. It could be either true or false. Not B implies A is true and alpha is false. That's how. So that's what the interpretation. Every row of a truth table for a given formula alpha is called its interpretation under which the value of a formula may be either true or false. And if everything, as I've already said, if all the interpretations are true, then it is called as tautology. A formula alpha is said to be tautology if and only if the value of alpha is true for all its interpretations. Suppose if all the interpretations are false, then it is called as fallacy. But but as of now, we need to focus on this word tautology, where every interpretation yields a true value. And now, based on this definition, we will be defining these three terms: validity, satisfiability, and unsatisfiability. A formula alpha is said to be valid. Look at this. When it is said to be valid, if and only if it is a tautology. What do you understand from that? The given proposition, we can call it as valid if for all the interpretations of the proposition, if it provides only true values. Just now we have defined what tautology is. If all the interpretation produce true, then only it is tautology. And if it is tautology for alpha, that formula is called as valid. Okay, next, a formula alpha is said to be satisfiable if there exists at least one interpretation. See, if there are 10 different interpretations, you see, look at in this example, how many interpretations are there? 4 different interpretations are there. This is row 1, row 2, row 3, row 4. Because I've considered 2 propositions over here, A and B as 2 propositions over here. 2 items, 2 units of information. So I had, suppose if I go with 3, 2, 4, 3, I'll have 8 different interpretations. 8 different interpretations I'll have. So I'll have, sir, good morning, sir. I'll have 8 different interpretations over here. So, based on that, you will have different setups. And out of those interpretations, if one of the interpretation is true, then we say that it is satisfiable. If all are true, then we say it as valid. Look at this. And out of all these interpretations,
good morning, sir. Reddy sir, can you hear me?
Yes, sir. Yes, sir. Good morning, sir.
Good morning. Sorry, I have bothered you in between of the class. As per the quorum of National Board of Accreditation, I am supposed to interact with my students.
Sir, definitely, sir.
Can I, sir? Can I?
Yes, sir. Please, sir. Please, sir.
Yeah. Good morning, all students, dear students. I hope you all are being safe at your place amidst this pandemic situation. This is just to inform you that I am Vishal Bhattar. I am a professor of Computer Science Department. I am here on online NBA visit, National Board of Accreditation, to your premises. And we need to interact as per the quorum of the committee with you on certain points. And I would request you, those whose I think the last 3 digits are your roll number. So if I ask you any specific question, please be vocal and let me know about the same. So roll number this 14014. I think please unmute yourself. So yeah, hello. Yeah, can you hear me?
Yes, sir.
Yeah.
Good morning, sir.
Good morning, beta. Good morning. I just wanted to know which subject this going on. The class of which subject is going on?
Sir, artificial intelligence, sir.
Okay, great, great. So how many classes have been over for this subject? In which unit you are right now?
So we are in unit 1 half, sir. It's a second unit, sir. Sorry.
Yeah. So okay, you are in second unit.
Yes, sir.
Okay, great, great. So uh, can you tell me what exactly are you going to achieve through your this BTech in IT?
Yes, sir. Sir, I wanted to do a software job, sir. By this department IT, I want to become a software employee in a
Okay.
company.
So the unit which is going on, the chapter which is going on, can you tell me what are the CEOs related to that? What are CEOs? Exactly, do you know what are CEOs? Course outcome, you know? Have you heard about this term, course outcome?
Yes, sir. I have heard about it, but not
Yeah.
exactly. I am this on this, but
Okay.
I
No
heard
issues.
about it.
Okay. Okay. Great. So now talking to roll number 12, can you just unmute? 14, you can mute yourself.
Thank you, sir.
14, you can mute.
Yes, sir.
Yeah. Good morning. Yeah. Good morning. Hello.
Good morning, sir.
Yeah, good morning. A lot of humming noise is there. I think some other person is also in the group who is sitting in your room.
Yes, sir.
So yeah. Now, can you just tell me, have you ever interacted with your alumni?
Sir?
Have you ever interacted with your seniors or alumni?
Yes, sir.
Are you aware the name of the student who got placed in IBM last year?
Not exactly, sir.
So when did you had your last interaction with your alumni?
Last. I have, it's our first year we have interacted with them, sir. After,
Okay.
during
Okay.
Corona, we have all online period.
So you are in which year? You are in
3-1, sir.
3-1 means third year.
Yes, sir.
Third year, first semester.
Yes, sir.
Okay. So being in third year, can you tell me the companies where you can go for the internships? Can you name me at least 5 companies where you can opt for the internship in the coming days? And which are those top areas which you have strengthened or which you are going to strengthen to apply for the internship? Which areas are your areas? Areas are your strength areas?
Google, sir.
Okay. So you know the procedure how to apply for internship. I am a training and placement officer, just to inform Reddy sir. I am fortunately additional charge of training and placement in my college. So
Fortunate, sir.
I am bang on target. If you say anything abrupt, I know how to get the internship in any place. I know exactly what is the package details of all the companies which can ever come in your Visakhapatnam.
Sir.
Okay.
Yes, sir.
So don't bluff, beta. Chalo, okay. This is for your benefit only. If you know the areas which are been in demand, that you can strengthen in third year, first semester, or second year, second semester, so that you are sellable. I'm sorry to use this word, but that is what the fact is in the national international arena, that you should be sellable. That means you should have that technological skill in you through which you will be in demand in the market.
Yes, sir.
Okay.
Yes.
So now coming to other aspects,
Yes.
you can mute.
Okay,
You can mute. Roll number 58. Roll number 58. Please
Sir.
unmute. Yeah.
Good
So-
morning, sir.
Good morning, beta. So I just wanted to know one thing that is related to your this books during the pandemic time. How are you able to access the books, reference books which are there in the syllabus?
So we are having e-library, sir.
Okay, so you are having those book. Can you tell me the name of the artificial intelligence 2 reference book universally used?
Sir,
Can you name me the book name of the books which are used universally for artificial intelligence? Chalo, I will. In one subject you have already cleared. I think that is theory of automata, theory of computation. Correct?
yes, sir.
That you have, I think, in second year.
No, sir, we are having now, sir.
Okay. And any other subject which are in second year? Which are the computer science subject in second year? Fourth semester, second year, second semester. Name one
Java.
subject. Okay, Java. Acha. So, beta, as you have gone through Java and Java is in great demand, can you tell me what is multi-threading? How do you achieve multi-threading? Can we achieve multi-threading in Java?
Yes, sir.
How? Hmm? I am not asking you to see the system and then tell me. If you know, let me know. If you don't know, let me know. I can ask you questions which you can even not find in the net. See, if you all people are well versed, we as a faculty, me and Reddy sir, are equally having the experience in teaching. And this corona pandemic is for us also. So we can see by seeing you what exactly is going on in your mind. Am I right, sir?
Yes, sir. Yes, sir.
So, and to be very honest, beta, you all people are in third year. Try to inculcate in you one very important feature, that is, you have to be true to yourself and to the organization to whom you are serving. Then only the path for the progress will be there. If it is there, it is there. If you don't know, just bluntly say, sir, sorry, I have no idea. That is much better and much appreciable. Many a times you get your things because of your truthness. Okay, you can mute yourself. Roll number 60.
Yes, sir.
Yeah, please unmute yourself. Yeah, yeah. Okay. Now, can you tell me which subject is taken by your HOD? Who is your HOD?
Padmashree ma'am.
Acha. Is she taking your any subject?
Yes, sir.
Which subject?
Automata theory and compiler design, sir.
Oh, great. Can you tell me what is Chomsky's hierarchy?
Sir?
You know what is Chomsky's hierarchy?
Don't know, sir.
Have you heard about this word?
No, sir, not yet.
Okay. Can you give me a simple application of finite automata in day-to-day life you might see? Okay, Acha, can you tell me what are PEOs?
Sir?
PEO. Have you heard about this term PEO?
Yes, sir.
Yeah, tell me, what is it? This is not something which you can by heart define. Define computer organization. This is not like that, beta. Acha,
No, sir.
Acha, one thing which is the problem for all computer science graduate, including Reddy sir and me, is that we have joined a branch which is ever progressing, day to day changing. So we have to be on toes from the day our parents thought that we should go into the IT sector. So pull up your socks and get ready. After 1 year, you are going to enter into an arena where nobody is going to tolerate your things which are childish, because at that time you will be paid. And when somebody pays you, you have to be very accountable. Am I wrong, sir? Reddy sir?
Sir, you're not wrong, sir. That's true, sir. That's a fact.
So let them be aware. Let them right now face the heat, which they are going to face anyhow after 4 years. You are going to enter into a worldly life which is full of hurdles, each and every step, and you can only overcome when you are technically bang on target, technically very strong. Correct? Okay, sir. Thank you, sir. I leave the class and I have to go to other class also. Thank you. Good day.
Thank you.
Bye-bye. All
Thank
the
you
best
very
to
much,
all
sir,
of you.
for your
And
suggestions, sir.
yeah, sir. All the best to all of you. Be safe. Be at home. Don't go out unless and until it is mandatory, and get vaccinated as early as possible. Thank you. Good day. Bye-bye.
Thank you, sir.
Thank you, sir.
Yes, how was the interaction? See, I don't know whether I'm fortunate or unfortunate. I try predicting certain things, and that's happening. Yesterday, I thought I was with an impression that I will be initially called for an interaction with the expert, MBA expert. It so happened that way only, that I was the first person who has to interact with him, and I have to explain, show the complete course file for the last semester, that's database management systems. It so happened. And that's the reason I was urging everyone, and enable your videos, go through the COs, be comfortable with the PSOs, the PEOs, run through the website. I have been asking you. And we should be fortunate. We are fortunate enough because this is the first class that he has joined. Now the other sessions also will be joined by him. And I've asked, indeed, he did not point out the strength over here. Our strength is 69 and we have only 40 students over here. Had he pointed out the strength of the class, we'll be in a different situation. I do not know what to say, and the CRs also will be in a state where they cannot reply. The reason could be, as I said earlier to you, that the MBA expert is going to join. That could be the reason the students might not have joined. Suppose if they are randomly picked up, if they are asked a question, they may not be in a position. There is nothing wrong. If you are comfortable, you may come out with an answer. If you're not comfortable, you may not come out with an answer. But whatever inputs that he has given, please take that in a positive way. And he has got good exposure to computer science and engineering. Okay, let's continue with our session. And now you can turn off your videos. That doesn't matter. Thank you. I'll share my screen. Yeah, let's get with our the three properties that go with the propositional logic. That's validity, the satisfiability, and unsatisfiability. And validity is depending on the definition of tautology. And what does tautology imply? Tautology implies if every interpretation gives a true value, then it is called as tautology. And if formula is said to be valid, if all the interpretations, only if it has, if and only if it is a tautology, means whatever interpretations that are available, all those interpretations are going to provide true values. That is called as valid. Similarly, if one of the interpretation gives a true value, then we say that it is satisfiable. See, a formula alpha is said to be satisfiable if there exists at least one interpretation for which alpha is true. That means for which the formula is true. Similarly, a formula alpha is said to be unsatisfiable if the value alpha is false under all interpretations. That means that is what falsy is. You consider, see, if I consider 2 variables, I will have 4 interpretations. If I consider 6 variables, I will have 2 power 6 interpretations, almost 64 interpretations. So for all the 64 interpretations, if I have the false value, if for all the interpretations, if it is unsatisfiable, sorry, if it is for all the interpretations, if it is false, then it is called as satisfiable. Look at these 3 definitions. If all the interpretations are true, then it is valid. If one of the interpretation is true, we simply say it is satisfiable. If none of the interpretations is true, that means if all the interpretations are false, then it's called as unsatisfiable. Okay? Moving ahead. See, these 3 definitions are important: valid, satisfiable, and unsatisfiable. Now look at this example. Show that the following is valid argument. What exactly do you mean by this valid argument? It's nothing but a statement that's being made, which could be true or false, a proposition. And what does this tell you? This is the statement given. If it is humid, then it will rain, and since it is humid, it will rain. Kindly understand this sentence. If it is humid, then it will rain, and since it is humid, today it will rain. Look at the first part of the sentence. This is only going to tell you if it is humid, then it will rain. That's an inference drawn. And now we are going to tell you that so today it is humid, so it will definitely rain. That's the conclusion we are trying to make. So this is the final conclusion. It will rain. So what are the 2 things that are appearing in this sentence? One is humid, the other one is rain. Kindly understand this. This is important. One is humid. This is how we represent. We try. I said now, the representing knowledge. We use this logic. Proposition logic also is to represent knowledge. This is the knowledge we have. This is the knowledge we have, and we are trying to represent this knowledge. We are trying to represent this knowledge. If it is humid, then it will rain, and since it is humid today, it will rain. So the key statements in this are, the 3 propositions in this are, one is it is humid, the other one is it will rain. So let me represent it is humid by A and it will rain by B. Now how do you frame this in proposition logic? A stands for this. So if it is humid, A, then it will rain. So this is implication. Up to this part, it is implication. A implies B. Now what does this implication imply? This implies that if it is humid, then it will rain. And there is continuation also, and. So we have used a logical operator. Since it is humid, it will rain. So this is our final conclusion. Okay, and it is humid. That is, humid is represented by A. So look at this. All this becomes the premise. All this becomes the premise. That is the left part of the implication, which we can also call it as antecedent. As I said, in mining concept, we normally use the word antecedent, but there is nothing wrong in using the same word over here. But in artificial intelligence, in propositional logic, we use the word premise. Okay, now this becomes, see, based on this statement, using these variables, we have represented the left hand side as A implies B, and A implies, what's the conclusion? It will rain, and B, it will rain is represented by B. So this it will rain. Is that okay for you? See, this is how the formula has been represented. The proposition, total proposition has been represented. This is a well-formed formula, nothing more than that. A implies B and A implies B. Now, how do you prove this? How do you prove this? How many different variables are there? 2 different variables are there. So how many different interpretations take place? 2 square interpretations take place. If there are n variables, you'll have 2 power n interpretations. So you'll have 4 different interpretations: true, 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 false, false, true, and false, false. Now we are trying to prove this using the truth table approach. So using the truth table approach, we can see that alpha is true. under all interpretations and hence is a valid argument. We'll later make this conclusion. Using the truth table approach, we are trying to represent this, all different interpretations. The first one is this part C, A implies B. I'm just denoting it by X, nothing more than that. A implies B. So recall your truth table, A implies B. What happens if both are true? It gives you true. If the right hand side is true, then also it will give you true. If both are false, it is true. If the left hand side is false, then it will be false. Sorry, if the right hand side is false, then it will be false. Sorry, if the right hand side is false, then it will be false. True, true, true. See, here you have false, true. Because the right hand side is true, it's true. See, if both are false, then also it will be true. Whereas in this case, this I've already explained in the last class. True, false, because the right hand side is false. Even though the left hand, the premise is true, the conclusion is false. So hence this will be false. So this is this part, A implies B. A implies B. And next, we'll go with this part, see, A implies B and A. So that's the reason I've used the small, denoted A implies B by X. So X and A means the total thing. So this with A, this is simple or and operator. True, true, true. And if both the arguments are true, then only it will be true. True, 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 false, 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 true, false, false, true, false. So this is X and A, where X is equal to A implies B. Now the conclusion, all this total part is denoted by Y. Now Y implies B, again implication. Now this is with respect to what? This and this B. See, implication again, this is true, so this will be definitely true. This is false, this will be definitely false. See, this is the left hand side and this is the right hand side. Kindly make that. So here the left hand side is false, but the right hand side is true. So that will be definitely true. This is false, both are false. True. So what are the different interpretations? All the conclusions are true. If all the interpretations are true, what did we say? That's what tautology is. And if all the interpretations belong to tautology, what happens? That is what valid argument is. That's what we said in this. See, a formula alpha is said to be valid if and only if it is a tautology. Yes, this is tautology because all the interpretations are true. All these four interpretations are true. So hence this is a valid argument. Valid argument. So this is the simple approach to proof. What is this? The truth table approach. Every one of us can do it. There's nothing wrong in that. Every one of us can do it. But what? In this example, I had only two variables. One is A, the other one is B. Suppose if I have 10 variables, then what happens? Can you tell me how many different interpretations take place? How many different rows do I have if I have 10? Can someone respond? How many different interpretations take place? Are you there?
2 power 10.
Yeah, 2 power 10 interpretations. What is 2 power 10 equivalent to? What is 2 power 10 equivalent to? It is 1024. So you see, as the number keeps on increasing, I've taken a small value for the understanding's sake, for the sake of understanding. See, if I have 2 variables, I have 4 interpretations. If the number of variables increase, then what happens? I'll have a very, very, very big table, and out of all that, I need not have certain interpretation. I need not require certain interpretation, but I have to, if I follow the truth table approach, I have to go that way only. So even though this is an easy approach, a simple and an easy approach, if you have good number of variables, large number of variables, you cannot be representing everything as a truth table. What I mean is, cannot be representing means, doesn't mean that you cannot do it. You can do it, but look at the time that you are going to spend towards it. Okay, so that's the biggest limitation of the truth table approach. So the limitation of the truth table approach is that its size grows exponentially. Yes, it's exponentially. If I say 2, 2 square. If I say 3, 2 cubed. If I say 4, 2 power 4. If I say 10, 2 power 10. If I say 100, 2 power 100. See, that's what exponential growth is. So if it has n atoms, then the truth table will contain 2 power n entries. Can you list out all the 2 power n entries and then construct the truth table and then give me a solution? We do not say it's impossible. It takes a lot of time. You need to consume everything. You consume so much of time, and in between you might forget some of the interpretations or some of the interpretations also. So that's a basic limitation. So truth table approach, even though it is a simple and straightforward approach, will not be considered as an approach which is extensively used. If the number of variables are to a limited size, then this is a very good one, a straightforward. But if the number of entries are too many, then the truth table approach should not be followed. This is where these approaches come into picture. See, in place of truth table approach, these are the other approaches that would be taken into consideration. That's natural deduction system, axiomatic system, semantic tabular method, resolution refutation method, and we'll be discussing one by one all these methods. See, all these are the alternatives in place of substitute. Is that okay? So we shall be discussing each one of these in the upcoming classes. This is what in the natural deduction system. See, as we are running with NBA, say, even though the time is also 9:50, so this is all the introduction to the propositional logic, and we'll be discussing each one of these alternatives in the upcoming classes. Okay. So I'll stop the session over here. I request the CR to please post the attendance. Very unfortunate, I had only 42 entries. Only 42 students are present. On a day where I requested everyone to join. CR, Meghna?
Sir.
Yeah, please post the attendance, Emma.
Yes, sir.
Wait till the CR posts the attendance. You may look at and conclude whether your number is there in the absentee list or not, and then you can leave. I don't know who the first girl. See, you are not number 14, I think. Hope you are not following my class. You said that you are in the mid of first unit. Indeed, we are in the beginning of the second unit. Yeah, good number of absentees. Okay, now you may leave. See, if your number is not among this absentee list, you may leave. నిన్న చెప్పాను నేను వచ్చేయండి నిన్న నేను అడిగాను పర్టికులర్గా మేడం నా క్లాస్ ఉంది